Hello, welcome to the Wolfi OS community call. It is January 11th, 2023. Um, who has something they want to share?
We have a bunch of new packages in the last however long. A bunch of folks went crazy and added a bunch of stuff. Do we want to what are the highlights? What do people remember adding? Bunch of real memorable ones.
I don't know, but the thing that was memorable for me is that ARM 64 is now available in production. So.
Oh yeah, awesome. And Rust. Since the last time we were here, we got Rust.
Yes.
And Memcached.
Yes.
I don't know what else. A bunch of stuff.
Erlang, Elixir, RabbitMQ. Most of the dependencies for FFmpeg are done, which means I guess FFmpeg itself will be done soon. But I would say the biggest thing is ARM 64 by far. And if you would like to elaborate on how we got there, that would be great.
Yeah, I wrote a blog post, which is linked in the notes, which sort of goes through how it starts as how we started x86 64 support, because we need to have tools to be able to build better tools, to be able to build better tools. So the first set of tools we used were borrowed from Alpine, and we used those tools to build slightly more of our own, and then we built slightly more and slightly more. Anyway, go read the blog post and I guess try to understand it. I sent it to my wife and she said, I know some of these words. I hear you say these sometimes. So it was well received in my house. But at the end of the day, the reason that we were doing bootstrapping, the reason I learned anything about bootstrapping at all was to do ARM support. I remember demoing probably 2 months ago, DAG executing builds on Kubernetes. Part of the reason we wanted to do that at all was so that we could run on non-GitHub Actions runners. Like for instance, GKE ARM nodes, which make the ARM builds tractably fast. So we went through bootstrapping on ARM nodes on GKE. Ooh, we tooted? Usually people clear the room. We went through bootstrapping for ARM in the process described in that blog post and briefly described by me just now. And then we got bootstrapping done and did all of the packages already configured in Wolfi for ARM again, and they all worked eventually, and they continued to work eventually. It's been a bit of a rocky ride keeping DAG working, but I think it works for the most part. And now we have a bunch of ARM packages, and with those ARM packages, we can package them into chain guard images, or you can package them using APKO into anything. So yeah, I'm really excited. We were single-handedly doubled the number of packages Wolfi produced in one day, or in one week or two or something. So yeah, pretty exciting. And most exciting is now it's done and mostly just works and is producing stuff in the background for us. Ariadne, do you want to hint at what might come next in terms of architecture support?
Sure. So we're experimenting with ARM v7. We might also do an i686 build, but I'm not really sure what value that one particularly brings. We had a customer, or not really a customer, but a design partner of ChainGuard, request ARM v7 support, so that one is definitely coming. We're also considering doing S390X and also Power. We might do Risk V64 as well, but that is to be determined at the moment. If there's any other architectures anybody wants, just open a bug in the GitHub or open a topic in the GitHub discussions section, and we can kind of talk through how to get there. There's a few interesting architectures to the open source community, like Lungarch and a few others that we might want to support just as an academic thing. But in reality, most Docker images and most deployments in general are x86 64 and ARM 64. So at this point, filling in the rest of the architectures is just largely an academic practice for us. And so we're doing that. We're using QEMU at the moment, although we are also going to try to see if we can source some actual hardware for like power and S390X maybe. But there's probably psychological trauma that will occur in trying to negotiate that with IBM. So it's kind of a low priority item at the moment.
Is the plan going to be to build ARM v7, build all the packages for ARM v7? I think for a while we had talked about only building some or something, but I don't actually know where that ended up.
At the moment, my plan is to just build all of them, and then if that winds up being too slow, we can revisit it. My original assumption is that we weren't going to have to use QEMU for ARM v7, but unfortunately, the way that G-Cloud provides their ARM nodes to us, we are not able to run ARM v7 bytecode natively on those CPUs. So that left us being stuck with QEMU at the moment because we don't have any control over that. So that might also be another thing to consider, like using Equinix Metal as an alternative source for an ARM builder, but we can discuss that at a later date.
Yeah, I don't know if I necessarily want to move to a bunch of different providers, but if it's fast. Also, I don't know, do you know if AWS Graviton instances would let us do that? Or is it the same problem that GKE has?
I think that basically the issues that all of these GKE, AKS, etc., I think that they're all building their ARM kernels with 32-bit support disabled. So
okay.
The Neoverse chip itself can run ARM v7 bytecode, but the kernel that is given to us as part of the runtime environment doesn't allow us to do so. Like, I spawned up a VM instance in G-Cloud manually and tried to just, run a 32-bit ARM binary, using like the Linux 32 command. And it failed to switch to the 32-bit mode with invalid arguments. So that would indicate to me that the kernel just doesn't support it.
Okay. Yeah, great. This is sorry for monopolizing all the questions. I just don't know anything about this. So I will keep asking them. But yeah, if ARM v7 is slow and we decide we want to build every package, we could use Equinix and get an actual ARM v7 thing hosted somewhere. There's then how to distribute the signing key to that is a difficult thing, but whatever. We can cross that bridge we can burn that bridge when we come to it. Cool.
Yeah, basically.
Thank you.
So the other thing that kind of is exciting to me, at least, is Dan Luring has written some custom YAML reformatting stuff that should make melange, bump, and other things that we do to maintain Wolfi a lot more pleasant than it is right now. Because right now there's issues where if there's trailing white space in a field, it'll like reformat the document incorrectly when you go to do like a programmatic edit. So having all of this custom YAML reformatting functionality, I think, is going to be a big win for enforcing the actual style that we want. And maybe Dan would like to kind of walk us through that.
Sure. Yeah. So first I'll just kind of show it. Let's see. It's probably pretty tiny. That decent. So yeah, anyway, I think the general goal is that we have all the YAML files, which basically are the essence of what Wolfi is, or how it's defined. I think we want to be able to scale up how we automate different aspects of maintaining Wolfi, which will inevitably mean making modifications of various kinds to these files. And we want that to be able to coexist with humans editing the files too, and just submitting new files to begin with. So yeah, we've run into different problems with different YAML formatting that can be. It might sound trivial, but it can be pretty obnoxious to deal with. So yeah, I started working on a tool. I think we'll open source it pretty soon, but it's called YAM. So like this is curl, for example, and this is a good example of a file where I think originally we had just a small thing. Like we had these empty lines that made it really nice to see the different data that we were encapsulating here. But when you do when you encode YAML back, if you're dealing with it in Go code, for example, either as Go structs or as the like YAML.node AST, when you encode it back to the file when you're done, it just like squashes a lot of stuff together in various ways. And I think the idea was that we could replace that encoder with a different encoder implementation that made it pretty, and so that like it's as if a human took a lot of time to make it readable. So anyway, there's this tool. And the idea is you can pass these gap expressions to, like, say, specify a node whose children should be split up by empty lines, for example. So if you do the root node, you end up with this. You have gaps inserted. Each section kind of stands on its own. You can have multiple of these expressions. So like, let's say we want each subpackage to be separated. We could run it again, but also add subpackages. Now each subpackage is kind of standing on its own. You can get down to any level. YAML is nested via mapping nodes and sequence nodes, which are basically like dictionaries and arrays. So there's that, but I think that's just a command line tool. I think the real idea is that we have a better way to programmatically edit these files. And there's something I've been working with. I haven't been too loud about it yet because I'm still kind of ironing it out. But in Wolfi CTL, our open source like Wolfi maintenance CLI tool, I've been working on some logic, kind of like what's intended to be kind of a central place to operate on collections of Wolfi YAML files at once. So you can in one fell swoop kind of like load a context that knows about the idea of multiple Wolfi YAML files, and you can select one or more of those files. You can do encoding. You can do like Go, like strongly typed aware operations on the data, and then re-encode it back when you're done to disk. So I'm still working on that. That's in Wolfi CTL. Let's see. Open. So yeah, I'll shut up in a second. But basically, this idea of this index configs.index type, there's a way to like create a new one, and you have access to all of Wolfi basically, and then can do programmatic operations in a way that's designed to scale and be type aware. So it's not just like one-off like sed edits to specific lines. Anyway, I can like word vomit more, but that's basically where my head's been at recently.
I think this is great because I feel like we're always like, oh, Melange is much better than many similar alternatives because it lets you write everything in YAML. And then actually YAML at scale also kind of sucks. I mean, everything at scale kind of sucks. But this is sort of the attempt to lasso in YAML at scale to make it automatable and sane, which is great.
Yeah, exactly.
You don't want to know the amount of Bazel format garbage there is. Speaking of stuff that doesn't work at scale. Sorry, we're recorded.
So, other than that, is there any sort of announcements that anybody else wants to make? Like, is there any sort of packages that anybody's planning to do? I'm planning to look at .NET in the next few days and get that done. But other than that, is anybody else working on any sort of packages or anything that they want to add? I know that there has been some work that Batuhan has been doing with like Spiffy and Spire and those projects, so that's pretty cool. But other than that, I plan to have .NET done, and at least ARM v7 is landing for one of our design partners probably this week.
Awesome. I feel like if James was here, he'd tell us the 100 packages he's currently doing, but we'll have to pretend.
He's presently doing packages, so that's why he's not here. All right, well, kind of not an eventful call this week, but then again, a lot of us have been out for the holiday season, so it's to be expected. We'll see you all again on the 25th, I want to say. So that'll be the next kind of community status call, and we'll properly announce it next time. But I'm glad that at least we had some attendees. So if there's anything else, we can probably just cut it here.
All right. See you, folks.
See you all.
All right, bye.
Thank you. Bye.